Start. Yes. A very good evening to all. I am Dr. Pratibha Jadhav, and I warmly welcome you all to the seventh session of the Parivartan Webinar Series, proudly hosted by Plastindia International University, Vapi. Parivartan Webinar Series creates a collaborative platform for experts across plastics, polymers, artificial intelligence, and sustainability to share insights and shape the direction of future advancements. Today's session will explore the emerging opportunities and innovations in the field of plastics and polymer engineering with a special focus on sustainable biopolymers, including compostable materials used in packaging, 3D printing, and edible cutlery. Uh, Before we begin the main session, I am delighted to invite Dr. Shashank Gupta, Senior Assistant Professor at the School of Engineering, Plastindia International University, to briefly share the university's vision and commitment to the academic excellence. Over to you, Dr. Gupta.
Before we hear about the session that is going to be delivered by Professor Mhaske, I'll just take 10 minutes of your time and talk about the university that we have set up in the state of Gujarat, that is Vapi. So, yeah. So PIU, which is Plastindia International University, is a not-for-profit institution which is founded by the plastic industry for the plastic industry. So as you can see in front of your screen, our parent body being Plastindia Foundation is interned by a host of industry bodies, of which the major ones are All India Plastics Manufacturers Association, there is CIPED, and there is Organization for Plastic Processors in India, OPPI, Flex Council, Indian Plastics Institute, GSPMA, and IPF as the main members, and CPMA, PMMA as constituent members, and a few associate members as well. So we are a university which has been set up with a clear vision of how we can give back to the industry and educate the students as a part of this process. Our vision is to develop world-class university in plastics technology, research, and innovation. We are conveniently located in the city of Vapi, which is roughly 150 kilometers from the city of Mumbai on one side and roughly 120 kilometers from the city of Surat on the other. Now, why Vapi is, if you look at the belt, which is roughly a 30 kilometer radius from the city of Vapi towards Mumbai, we have Umargaon, and going further, we have Vasai and all. And when we go towards Surat, we have Valsad. So, if we look at this 30-kilometer radius with Dadra and Silvassa on one side and Daman on the other, we are looking at a major plastic sector or a processing cluster of the country. That is the reason why this university has been set up in the city of Vapi. We have an academic partnership. It's a technical partnership with University of Massachusetts Lowell, which is a sister institute of MIT that we have in the USA. This Lowell campus is situated around 60 kilometers from Boston. So there is a growing need to increase employability through skill development programs in India, and that is the effort that we want to bring in. Plastindia International University, as we have already mentioned, has signed an MOU which was just renewed in the month of April, the first week of April, where we have extended it for another 5 years. We just look at the criteria under which this technical partnership has been striked out. Designing of curricula and modules in plastics engineering. So Professor Mhaske also happens to be a part of our academic council and board of studies as well, where we have industry stalwarts and academic stalwarts like him, helping us to, modulate our syllabus in collaboration with UMass Lowell. So whatever is being taught at UMass Lowell, we are teaching them, and then we are trying to fill in the AICT criteria that is there in India, which is 160 credits. I mean, in the US, the credits which are required to be passed out are lesser. And then we have also included subjects based on the local knowledge that is required, at least to serve in India. We have student and faculty exchange for research based lectures, discussions, applied research, and community based projects. There are opportunities for engaging students and researchers to have a like for like peer relationship and to have a mentoring opportunity. Some of our students can mentor their students, and it can work likewise like that. There is also a criteria which is signed up with respect to faculty development. So faculties from PIU WAPI will be sent to UMass Lowell for their training, and there will be faculty development program which will run up to an year. in these terms and conducting a webinar series in technical partnership. So we are looking at the second of this series. First, we have already done the last year. For those who don't know about UML, it's a 70-year-old presence. They've been teaching plastics since 1954. It's a leading institute in plastics technology. Now, why one should think about PIE? There are a lot of institutes which are running, programs like polymers. Very few like ICT, which have been specifically focused on a particular domain, like ICT focuses on chemical technology and chemical engineering. And in the same way, PRU focuses just on plastic and polymer engineering and technology. So we are not just a course, but an exclusive university which is focused on just the plastic and polymer engineering courses. We have industry driven education, so we have very close ties with industry partners, and hence our curriculum is basically futuristic. It is not what we require today, it is what is required going to be required in 4 years or 5 years down the line. Very strong industry integration and hands-on learning. We have a guaranteed placement which is 100% guaranteed in terms of getting placed. We have scholarships and financial aid, so we have our own industry based scholarships, and then we have these government scholarships as well. And all in all, it's a gateway to global education and excellence where we run programs where students can go to UMass level, get into a global immersion and a cultural exchange as well. Now, the scholarships that I was talking about, there are four different categories. One is merit-based, where we give you scholarship based on your marks. There are need-based financial aids. There is industry-sponsored education and government scholarships, as we are UNICE and AICT are recognized and approved institutes. Needs-based financial aids are for those students who are coming from economically weaker backgrounds. So the return on investment is really very high, and we guarantee placements. We also run a refund policy where if a student comes up with a 6.5 CGPA, and if we can't guarantee a placement, we give away the fees which we have taken from the candidate in the past 3 or 4 years. These are global faculties. So on the left hand side, you can see the faculties which are there at UMass Global. And on the right hand side, we have a lot of industry experts, both in plastics and polymer and computer science domains as well. Faculty consists of people who are studied from very reputable institutes across the country. Even our visiting faculties are having PhDs from reputed institutions like VIT and all. And I mean, the lowest that we have in terms of experience is 3 years, wherein the highest that we have in a small team that we have at the current point in time is 30 and more years. We run these two programs where we have a BTech in Plastics and Polymer Engineering with the first year and a direct second year entry at this point in time this year, and a Computer Science and Engineering. These are some of the companies with whom we have signed MOUs at this point in time in the first year itself, who have very openly welcomed students who will be passing out in their companies for placements. This is an annual tuition fee, 75,000, may increase by 10% this year, and a one-time deposit of 12,500. We have 30 seats to be taken from Gujarat and 30 seats from all India. The eligibility is very simple and it's very similar to what we have in almost all the parts of the country, which is PCM 10 plus 2, 45% of theory and practical marks for general candidates and 40% for reserved categories. And when we are talking about an entrance exam, JEE mains or good set, which is for Gujarat suffices, or if a student is coming from a diploma background, he should come up with a 45% score in open category and 40 in reserve. So this is the campus that we have. Just a few glances about the campus because we are connecting virtually. This is School of Engineering building, and this is the campus that we have, which is roughly around 37 acres. This is our front gate, the entrance gate to that 37 acres of educational excellence. This is the School of Engineering building. I am currently seated on the ground floor of this building. This is our classroom. So we have interactive learning environment with smart classroom equipped with modern teaching technologies. So these smart boards are interactive in nature. A student can connect with their own laptops and interact with the faculty on digital panel. This is a group of students performing chemistry experiments, viscometry for molecular weight. This is our workshop and processing house. Again, students operating the machines, state-of-art laboratories. We have a computer lab with 60 seating capacity, a lab which is very identical. So we run a software-based language, English language curriculum where we have 2 semesters, theory and practical, where softwares in terms of English language help the students with respect to listening and speaking skills, whereas the theory part takes care of the reading and the writing skills. We also have a 3D printing laboratory, and in both the semesters, first and second, we expose our students to subjects such as design thinking and innovation. This is our library, both digital and the analog that we have. Sports and recreational facilities, yoga, important for mindfulness, focus, and overall well-being as well. Hostel facilities that we have, fully furnished 1 BHK and 2 BHK apartments, being given at a very lower price. Just a glimpse of our students collectively, standing outside the campus. There's a cafeteria and common room separate for both girls and boys. Just an image to, foresee what is going to happen in the future. We have our own buildings for the School of Executive Management, School of Sustainability, and School of Continuing Education, along with an auditorium. So this is the plan that we want to have in the future. With this, I'll end up my session and I'll pass it on back to Dr. Jadhav. Thank you for listening.
Many thanks, Dr. Gupta, for sharing the valuable perspective on the mission and vision that guides PIU. Let us now move ahead and introduce our speaker for the day. We are honored to welcome Professor Shashank Mhaske. Professor Mhaske is a distinguished expert in polymer and surface engineering, currently serving as the director of ICT Jalna Campus, Dean of Research and Innovation at ICT Mumbai, and professor in the Department of Polymer and Surface Engineering. With over 2 decades of experience, he has authored 222 international peer-reviewed research papers. He holds more than 8 patents and has supervised 18 PhD over 95 postgraduate scholars. Dr. Mhaske has successfully developed and transferred technologies to more than 30 leading industries, including Asian Paints, Unilever, Praj Industries, BASF, and Deepak Phenolics. His research spans bio-based polymers, specialty coatings, sustainable packaging, responsive materials, and recycling. He is recognized with Maharashtra Academy of Sciences National Award for Technology Innovation in Green Polymer Materials and Products by Ministry of Chemical and Fertilizers, Government of India. Bellocker Academic Excellence Award and ICT's Best Teacher Award. He is renowned for converting cutting-edge research into real-world industrial solutions while fostering innovation and academic excellence.
Thank you.
Thank you. Good evening to you all, and thank you to Dr. Prashant and Madam for nice introduction. And now to set with, let me share the PPT which I made it for you for today's session. And once you could see that, you just
Yes, sir, visible.
Yes.
hope now it is into the slideshow mode. It is into the
blown up mode. Yes, sir.
Yes, thank you. And I'll be talking on opportunities and innovations in plastics polymer engineering and the way forward for plastics and polymer engineering. So let me give you some glimpses before to go to an innovations and the opportunities in polymer engineering and specifically to an plastics. As we all know, the current plastic consumption, which has been increasing in leaps and bounds in a very short period or expedite mode. So considering the today's US per capita consumption of a plastics, which is 108 kg plus, whereas in China is nearly 56-57 kg per capita. Global per capita consumption, which is more than a 30 kg average. And we as an Indians have now also lead to the 14.3 kg per capita consumption in today's context. Whereas if you see the divide into the different region where plastics has been consumed into a different region of India, you could see like how it is. And the Indian current market, which is like even the CAGR figure of 6.6 growth rate to 6.8 now rather. And the USD wise 44 billion USD market, which is now going to hit it towards an 70 billion USD market as an plastics. And with the good note, which we all know recently, the financial power and the strength of the country, which we are the fourth largest economy of the globe, which we have surpassed the Japanese financial status. Considering this growth, which is the context where polymer is also, or the polymer or polymer and allied industry is playing the pivotal role in increment into this financial growth of the country. If you all see, dear friends, is like we currently live into the plastic age. So there was a stone age, metal age and all that way, which we have seen it into the ancient literature or the historical context too, where in today's context, which we all can say, we live into a plastic age. And as we live into the plastic age and the consumption patterns of India into the plastic specifically, which includes all thermoplastic thermosets and the part of the rubbers too. So, which is we are going to hit in 2060 the same like and what the states has been doing it, which is 165.9 million tons as on the production and the consumption, where we are currently, which is in the range of 2025, if you see it, like less than 50 million tons, whereas we will grow by 4 times bigger than what today we are. With this, if you see, the most alarming feature is like threat to the plastic waste. Threat is not in terms of the common one which they are talking about banning the plastics and all. I am talking the threat to the plastic in industry that way, like how we can manage the plastics which has been produced and consumed to and the Indian responsible citizens. So consumption is bound to increase, which we know. But as the consumption will increase, the wastage will increase. And accordingly, as the wastage, the leakage to and the aquatic environment, the seashores and the aquatic environment, which will make a pathetic situation if we won't able to handle it properly or we won't be able to deal with properly. You might have been thought it like why I'm been talking to you related to this to give you all is like you are into the right field of polymer engineering and technology specifically because the today's world is a plastic world and the tomorrow and day after too, whatever the anticipations of your timeline, you will be into and the safer hands into and the polymer as and the career. However, as we do it that way, there will be an the associated issue how to tackle and how to handle the plastics which is being generated. So doing it so, we have to really see what sort of innovation and opportunities available. Once the plastic has been born, we'll see that. And then the second part of my session, which we will give you like before born, what sort of things which we can do it as on the innovation and opportunity lies with that. Once which has been born, that has to be tackled it first because which has already been in existence. So this is very common and the very the broad way which will give you on the horizon type of picture, which is what we all know. You all are from the fraternity of the polymers, utilization, technicality, professionalism into and the polymers. So you know what is commodity, what is engineering, what is specialty. Though the definitions are been diminishing now from commodity to the engineering, when I was been doing it my undergraduate program, few of the plastics which were into and the engineering category, now which we have been teaching to students, that has come to the commodity plastics. So as the plastics consumption and the patterns and the opportunities are been increasing, even these lines are so thin and which get diminished over the period of time, and we all consider it in terms of the polymer which has been generated. Don't worry, these pictures and this pictorial format is very common to all, which you all must have been seen in many places, which I don't want to elaborate on. My aim to tell you guys to in terms of learned people into and the polymer or into and the aspirants into the polymer to be considered as and the profession future. Only mechanical recycling, by which we can think of like how to manage the garbages, how to manage the landfilling, how to manage the per capita consumption of the plastic increment into the EPR norm and PCR norms. Rather, the chemical recycling is also one of the important and the crux through it, by which you can get into and the value added products. So waste to wealth is the possibility to go into and the chemical recycling. This particular chemical recycling in which I am given you and this flow chart is as simple and well studied, well learned and well published, which is in chemical recycling of polyethylene terephthalate, which is saturated ester, which will give you in the different attributes, which is like glycolysis, methanolysis, aminolysis, hydrolysis. In this case, if you do it into the glycolysis, then you have bis hydroxyethylene terephthalic acid. If you do it and the aminolysis, then you will get it bis hydroxyethylene terephthalamides. This sort of output which you will get into, which you convert into and some value added product like an plasticizer, lubricant, or blending or grafting with something else to form it as a value added. But the innovation which has been happening in this case is not this. Here I am starting like what opportunities and the innovations are. The innovation into and the PET recycling, where in India, I am not saying that nobody does. People are been doing it, but not into the scale where India is producing the PET and using the PET with the different applications of PET. The vulnerability comes through and the recycling of PET at the end up with PET recycling with mechanical to convert into and the scraps, fiber, textiles, then some sort of chemical recycling in terms of glycolysis, methanolysis, aminolysis, but the right set of things on the basis of the acquaintance of mine with the PET industry and the research too. The only option which I feel so to be dealt with and the PET in this case is a polycondensation reaction, which we all can know is a solid state polymerization. This particular plants of SSP, which I have practically been seen is running into and the huge capacity in China, specifically to and the Guangzhou and all that kind of province, where they do it and the PET recycling, which is by solid state polymerization, which is polycondensation, to get a monomer recovery back. Terephthalic acids back, by which you can again make it as an the PET. So you will be you no need to deploy. One is like the natural resources or fossil fuel, or you no need to do as much of the recoperations to convert it into the newer options. So SSP is something which is the opportunity and the innovation happening into and the polycondensation of PET. So please look into and the polycondensation of chemical recycling of PET. I'll be giving you so many food for a thought out of this today's session, by which you can select your right set of areas in which you can work in. If you are into and the student or the professional life, so you can select it and right set of projects to deal with, or from the professional industries and corporate world, where you can deal with your polymer as a backbone and diversified your business perspective in terms of the opportunities where the innovations are been happening. So one of the best innovation, which is not a recent now, which is quite well known and acquainted with the rest of the world, but in Indian context, we are still been not so versatile to know into and polycondensation reactions of PET at the larger scale by solid state polymerization. Second one, which is like, which you all know, the PCR, which is post-consumer recycle or recyclates, to be used into and by norms in MPCB in state of Maharashtra, in Gujarat Pollution Control Board, or in largely as an CPCB, which is Central Pollution Control Board. They have released certain norms by which you need to use it and the PCR to your material of certain applications. It is not into the pharmaceuticals or food or confectionaries packaging, but wherever it could be, where you can always use it and the PCR as one of the ingredients. So innovations and the opportunity lies with utilization of right set of PCR. Take it from me, it's not that easy to just mix it a same class of a material with the virgin base and achieve the property, because PCR sometimes adds obspec. PCR available commercially are same like and the virgin base looked like. But as polymers are molecular weight distribution concept, it has a different packing density, and due to which as end of the product, which I have seen it through my industrial consultation with the industrial setup, addition of PCR may produce a good article at your factory end, but over the period or might be into the very short period, it start giving you a stress release, then it will give you a crack filling, it will give you the roughening of a surface, it will give you a slightly yellowing to the surface, and at the end we always can talk about PCR are been added. So as it is a post-consumer recyclate, you bound to be have it a deteriorated property than that of the virgin base. But my dear friends, the opportunity lies with working on PCR in thermoplastic polymer engineering industry setups, not only to an academia or into the research perspective, but even lead to, because this particular topic can lead to the industry by which they can save it well, not financially only, but rather to the environment and to the governing norms too. Because lowering PCR plastics, it will reduce the cost. Improving the color properties of the light or pastel shade products with PCR is not that simple, which you could see. So you need to have a certain innovation to be do it in terms of selection of dispersing agent, right set of additive, right set of the pigment at its chroma and the hue value. Chroma is the purity of a colorant, so you need to select it the right set of purity of the colorant, by which virgin material may give you that sort of LABCH value, but addition of PCR may deviate from the spec due to the purity of the color is not being shown to the product. So there the innovation lies for us, where we can develop a certain technologies, develop a certain proof of concept into such a way that the PCR can be utilized at the good level of concentration, not to an 5 or 10%, which we can lead to a 30 and 40%, by which the virgin plastics consumption to and the secondary applications can be reduced. So here the material can be a material know-how and selecting the proper set of PCR, as well the giving the right set of additive package along with PCR is the innovation needs and the opportunity lies with. So please do consider this is also a second thought onto, and the opportunities can be even at the commercial setup or at the uh, financial strategies to be worked with the polymer industry. Okay, this is something which I'm just been giving you in terms of the eye-opening to you all. The PVC, polyvinyl chloride, doing it and the recycling of PVC, where the chlorine labile to and the CH2 CHCl, the hydrocarbon resin that way. But this methyl group, due to and the thermal degradation, converts into HCl, which at that temperature converts into gaseous format, is vulnerable to be controlled it at the shear mechanisms which we worked with engineering processes like extrusion, moldings, compressions. So the PVC recycling also needs to be looked into in the better way, where the PVC recycling or the PVC development, which we can upgrade or upskill the grade of PVC, not only by addition of the plasticizers like octyl or butyl phthalate, which is not all the way now. Even the adipates and succinates or the green plasticizers are being available, where phthalate-free plasticizers are being used. But adjusting the elasticity, adjusting the softness to the plastics is not the end of it. We have to look into and the additive which has been added into the PVC, because which we all know PVC is not a melting, it is a sintering process, due to which the K value is the important one. And once you start doing it as a recycling of PVC, you won't be able to lead to and the same application of PVC where you have started. So please look into and that sort of PVC addition, where the heat stabilization beyond initially was TBLS, DBLS, LS. Even I know the days of litharge where was being used as an heat stabilizer. Then tributyl lead stearate, dibutyl lead stearate, two lead stearates, two one pack stabilizers, two, and now a barium cadmium, calcium zinc, liquid stabilizers. Beyond which the stabilizers which will be give you and the zero VOC, and the same stabilizers can impart to and the good flame retardancy or the electrical property in terms of breakdown voltage and arc resistance is the innovation needed in the PVC industry and the opportunity where the PVC processors and manufacturers can deal with. Second one, which is again and the polymer, which can be a alarm to talked about in terms of the recycling is concerned, which is styrene. Because polystyrene is been into and the PS, HIPS and EPS. Expanded polystyrene recycling is the challenge. So please look into and the expanded polystyrene, which is EPS. In this case, which we all know by the brand name called thermocol, which is low in density, used and blowing agents, so flammable even so. And densifications of the PS is something which is like only densification and converting into the melt to form it as a polymer melt by PS is a good for demonstration. But the consumption pattern of PS and the EPS is huge. And in that case, the pyrolysis, oxidation, polymerization modifications are the innovations which is been going on, by which the oxidation you will get it as an benzoic acid. If you do it and the post polymerization modification, you get it on a fluoroalkylated PS products, which will give an different dimensions of the product in terms of the applications are concerned. So not only converting into a mechanical recycling, please do look into an its value added product by pyrolysis like benzene, toluene, and ethyl benzene, etc. by can be utilized as a precursor for some other value addition or other polymers to be formed in. Again, related to the recycling concepts are acrylic, amides, carbonates, urethanes. This is something which is carbonates, which we all know, phosgene, so bisphenol A, phosgene. These are the precursors by which we convert into and the carbonates. So recycling of carbonates. Urethane, which is different ester polyol, ether polyols with MDI, TDI system are a challenge to convert the polyurethanes into recycled polyurethane back to form it as a recycled polyols. So we no need to use it and triglycerides formations or any other resources to form a polyol. And most close to me in today's research activity, even at the my research group, which I am been doing it, which you all can be think of, where into and the don't think only the polymer is the injection molding, extrusion, thermoforming, calendering is an area. Polymer is an materials engineering, material science, and these materials goes with a different dimensions. Three dimensionals are engineering processes, coatings, one dimensional process, which you coat something, adhesives, paints, and the resins. Once we apply onto the substrate, once the demolishing the buildings or removing the paint for the repainting and all, it always goes with the debris will be put it into the dumping will leach out into this paint or the adhesives, which is quite vulnerable towards the soil fertility. So needs an opportunity to look into and the how the best recycling possible with and paint, adhesives and the resin or the coating system, even to and the stationery where the waxes are being used. Only changing from solvents based to and the water based will not change the world. Even the days have come now, and thinking towards an carbon footprint, we need to think related to the recycling of the coating system. So if you could able to recover something which to and the good product into it, or may not be a product, but at least you can dispose it well, even we will be happy or we will be a responsible citizen to this globe. The one good example which I have seen it practically and which has been even published into and the open literature and the scientific literature, where waste to energy. This all know plastic waste to fuel, plastic waste to gas. The important part which I want to catch your focus on, the opportunity lies with converting the polymer waste to the electricity. The gas and the fuel which can be converted into, but we won't be lead to and the same calorific value which fossil fuel based fueling systems available. So which needs to have certain mixing, needs to have some sort of addition to this to convert into and the right set of fueling systems to the vehicle. Whereas and the in countries like Netherlands, like in Endovan and all, they generate the electricity out of plastic waste and utilize this for civic applications, for street lights, some to an amusement parks, and wherever the public places, the electricity utilization from the plastic waste rather than the hydrodynamics. So we can always solid onto and the thermal power plant or the replacement to an renewable energy to and the solar based. We as an polymer engineers can look into and the waste utilization of the plastics converting into the electricity as an the energy source. And at last, which we all can talk about, sustainability. So sustainability is the buzzword everywhere. It has been good selling word, which is like an sustainability. Sustainability is the gamut, whereas on the polymer sustainability is something which we need to be focused. Sustainability is the approach rather, and we have to give that approach to the polymer industry by which we can be into and the sustainable globe. Sustainability is just spend me a half a minute onto it. What do you mean by the sustainability is not only converting synthetic to a natural is a sustainable. Sustainable concept is like when you are producing the product where the staple agro material will you be using it, whether the nearby populations will you be using it in your process, where for the needs into and the local vicinity could you able to satisfying that. If this all concepts leads to your product, then only you supposed to call your product as a sustainable. Only changing precursors from fossil fuels to and the natural resources is not an only a sustainable model, which may be a innovation to be called it as a bio-based plastics, which converts into an biodegradable, and even so onto and the better perspective to biodegradability, you can even think for the industrial composting or the home composting. The figures which I have thrown it to you, which is into and the current concepts of Indian per capita, which is like 14.3, and out of which 2% also you convert into the bioplastics, which is also very large, but I am just taking it in hypothetical case of 2%. Then that amount of plastics, if you want to really do an biodegradation with an composting, the amount of land, amount of space which you need to do the land filling for that particular short period, not no long like in dumping yards, which currently we are been using it, but that much land is not been available to just to destroy a material to convert into an disintegrated part. So right set of innovation into and the bioplastics, as far as my opinion goes, is like develop the polymers into in a such a way that it will give you as an anaerobic digestion, and anaerobic digesters can be installed for composting the bioplastics. So that way I'm talking about and research and innovation in bioplastics, and this is the particular area when my introduction was been given in which I am been working. So not only been utilizing this sort of material which is bio-based like lignin, cellulose, then chitosan or chitin, chitosan, poly. In broadly, what I mean to say that the carbohydrates and polysaccharides are not the only options, or polyhydroxyalkanoates are not the only options to be converted as an the environmental friendly or the green material. The current so this particular schemes which I am been currently working into the ICT, where the innovation is been going on and the opportunities lies with the commercialization, which now onwards I am been throwing into the rest of my session, which is bio alkene system-based product. So where the cellulose is the material which is abundantly available everywhere, and which we are even been available from the paper industry waste as an lignin, and the cellulose is from the agro. So this can be utilized and converting into a fractionation to convert into cellulose to and the glucose to bioethanol, bioethanol to bioethylene, bioethylene to and different biopet, biop, biopvc, butene, then biops. So these all fossil fuel based hydrocarbon resins as well as saturated esters resin could be possible, because once you go get into and the glucose, you have the option to be available and the opportunity to make the bio-based monomers in the India. So currently we have biopet, and we have certain technologies available which goes into bioplastics, but not the scale which we supposed to have. So opportunity is in India for we all of us is like to work into such system to give as a right set of efficiency and efficacy to the our developed technology by which the commercial models can be erected. So here, this sort of innovations are being on, and this particular scheme, which even I presented into IRC, which is Indian Rubber Congress to Chennai 2 years back, and which was appreciated as well. Not only that way, even the companies like Michelin and all, they have come up with this technology for demonstration, which is bioisoprene. Bioisoprene is the precursor for the rubber. So rather than from natural tree secretions or the tree gum, on the basis of the glucose molecule converting into the isoprene to and the renewable rubber to be used for tire industry or the bioplastics is been innovations. And this particular link which is mentioned here, if you go through the whole detailing of all these schemes with the modifications are been available. Once you get into and the isoprene, then you are into the top of the world, where you can change the chemistry and convert into and the elastomers at the different hardness with different applications, and use it even to an the smaller segment like an plastic toys, and to an the bio rubbers for an certain applications may not be and the only applications like a tire or a wheel to an automotive industry, but wherever they need to have it as an see the why the innovations need in this. Everybody is talking about the biopolymers or bioplastics needs to be use it in place of synthetic. Once we use it, then it will be an biodegradable or compostable. But the drawback is you cannot diversify it into a many application where you need to have the service life long. The benefit is like the service life shorter, but one disadvantage to this is like as service life shorter, you won't be able to move with a certain application. Let me throw some light onto this in terms of the application to give you is that bioplastics and all has been moving very well with FMCG market. It has been moving with an very good with pharma and the food products, which have a lesser time frame or lesser time service time utilization. But we won't find it as on the bioplastics used into and the electrical and auto OEMs, where this particular material has been going, where if you go back to our visual, if you can recollect my first slide, you can see the larger consumption into the injection molding, where the automotive sector is taking the larger share of the cake. In that case, though we develop the bioplastics or biomaterial, we won't be able to lead to the versatile application where this consumption pattern will increase. As the consumption will not increase, the cost of the biopolymers, no one can give you that way. So we as an engineers need to give to the industry in terms of the innovation into an increment of the service life of the biopolymers, even so for certain application to be targeted. So what are the thermoplastics which I have talked to you. Now, few of the example in the polymer engineering, we have thermoplastic thermoset. So I'm giving some example, which is like the bio-based epoxy resins. Then petroleum-based epoxy resins are there from the vegetable oil, which is which was a innovation. Now people are talking wholesome of epoxy resin, which is bisphenol A with epichlorohydrin as the reaction system to convert into the epoxy. To convert the bisphenol A from the molecules like an polyphenolic like lignin can be used it, and then convert a petroeconomy to a bioeconomy more into the polymer industry. So certain sort of even into the lignin, if you all can see, the lignin have lignosulfonates and goes into the construction industry. However, the lignosulfonate or the construction industry for waterproofing and other applications is not only a stoppage. We can always think for the lignin as a precursor for a polymeric masses to convert into a value-added product. What other innovations and the opportunity lies with we all as polymer engineers to make it as some blocks to be entered from the biomaterials to 3D printing? Good, happy, but should not be happy at this moment, only to be changed from certain synthetic plastics. Some blocks are being utilized by the PVA and PLA and on PLA with different addition to be utilized as a biomaterial to 3D printing. However, if you see it into the current thrust which we are being stoppage onto and the 3D printing extension into the different application of electronics and electrical and auto appliances or auto OEMs specifically, because 3D printers are being available, the high precision level, high controlled 3D printers are available, but the materials which we are being using into the 3D printers still today is not being produced into the country in the larger extent. So we are being still restricted on the imports of utilizing such material for 3D printing, and at the end our 3D printed product cost is going havoc. So the industry or the consumer will not be appreciated for buying. They appreciate your innovation and the concept, but buying will not be appreciated because at the end you will be end up paying more. So we all supposed to work on to and the materials development for 3D printing of different application for DLS type or DLP type. These are the 3D printers types on which we are been using it. So we can develop certain materials which go into dentistry, which go into the biopharma applications. And these materials will be taken up by the pharma industries to produce it here, by which the cost to the service or cost to the consumer will be reduced, and the treatment can be gone to and the different strata of the population of the country, and there we can always can be satisfied as a polymer engineer. We can read to and the lowest economic strata of, we are providing the good medical services because of the material cost reduction. Then opportunities which have already been talked to you in these of bioplastics and biopolymers. Now, one more part where innovations are required in the country now, which is like PFAS-free materials needs to be developed here, which is polyfluoroalkali substances are being added into many processes, which has been banned recently into the Western world, specifically in the European continent, and due to which the bio rubbers or the rubbers where fluoro systems were been going on, even to the binders or the polymers which goes into the different applications of the paper industry, where PFAS free materials are in demand. Me at the ICT has been working with few of the in India foreign multinationals here or into the Indian polymer development companies, R&D companies, for which we are developing some PFAS substances for different applications. So please be looked into this PFAS free system and worked into it. There is too much of opportunity lies for the Indian polymer engineers to be developed and the faster innovations into PFAS. At the end, which is like towards the last 5 to 7 minutes on what exactly the research activity which I am been doing it with my research scholars here, is like the bio-derived PUs. So bio-derived PUs is not something new which people are talking about. Bio-based PU or water-based PUD or PU polyurethane dispersions or water-based polyurethane WPU or PUDs are been available. Whereas on the different concept which we have put in and published, which is from cardinal based chemistry, which we have converted into and the WPUD. So it is not only WPU, not only the PUD, it is WPUD, and which can go into and the thin layer applications. Thin layer applications of PU can be used into and the protective layers which are been going as an polyurethanes, where these WPUDs are been used very well, which has been developed from agro waste, which is cardinol. So cardinol, which comes from CNSL, cashew nut shell liquid, where cardinols are available, and these cardinols are being used as a precursor. This particular scheme is been published and it is been ready for available of readings out to everyone. Second one here for the starches and the carbohydrates, which all whole world been talking about. I have concentrated my focus onto and the staple food of the country, which is swargam, which is jawar. And we have extracted the protein from the jawar, which is caffeine. And we are the largest producer of swargam. So we have the wastage of swargam. So we have utilized an waste swargam and extracted the caffeine as a protein, which is an elastic protein. Then we have modified with different plastication to this to convert into and the different elasticity. And I must tell you here, one good part is like the elasticity gone up to and this caffeine based polymers is as a very near like an TPU. So we could able to get and the best sort of elasticity out of as an our own food waste, or the not a food, the grain waste, the agricultural waste, which is swargam, and then jawar, where this innovations was been done, patented and published too. And one or two industries whose names are not been taken it here because we are under the Indian MOU are being used for their primary packaging applications, which can go into an eatables, which can go into and the ready to cook substances and all with the technology developed in my lab here in ICT. Then few examples onto as an sustainable conversion from cellulose to cellulosic esters, where I was been talking about to give into and the plastication or esterification by plasticizer application, as well as addition to and the PVC, by which we can replace the even adipates and succinates, not only the octyl and butyl phthalates, but even adipate and succinates from the cellulose. So valorization of cellulose is cellulose, lignin, chitosan, capacaraganan. Valorization of such system is required in today's context in the country, where we are having an abundant availability. Second thought which I want to throw it here is like we as an India is the second largest producer of the seedlac. The first one is the Thailand, second is the India. The difference only between the India and the Thailand seedlacs, the Indian seedlac is slightly darker in shade. So we as an, and seedlac is a polymeric. So you all know into an our ancient literature or religious literature, even to and the Mahabharata and all, the shellac house or lac house was been burnt and all, which is nothing but an seedlac process to shellac. And Lakshagruha, it is nothing but an the lac house in which the seedlac to shellac was being used, and this particular shellac have an application into an confectionery industry, but not yet come to an the coatings, polymers and other industry too. But it has a good adhesion property. Only the crux left behind is the color. It is very dark in color, so decoloration and devaccination, because it is available, it has an inherently packed with the wax, and wax will give you the migration. So decoloration, devaccination of the seedlac is also on the topic for the research and innovation, where the opportunity lies for Indian researchers to boost the economy of Indian context. With this all background from last 22 years of mine, which I have been doing it, I have as a center of excellence and innovation, which has been funded by the industry, which is one of its own kind of the ICT, which is completely been funded by the industry, not by government funding based upon. and where I only worked on to and the rightly focused on polyhydroxyalkanoates. So not on PLA only, or we have been working on hydroxybutyrate, copolymers of hydroxybutyrate, and its versatility in diversifications of the applications of polyhydroxyalkanoates. So please do work on to an biopolymers, not exactly the polyhydroxyalkanoates only, but PLA also. PLA, which is not only the source as an lactic acid from the corn, you have different sources of lactic acids convert into and the PLA. So this can be a synthetic bioplastic. I mean, the synthesized or fermented bioplastics. It is not naturally occurring material. So when the consumption will increase, we don't have the availability of the natural occurring polymers to that extent where we can satisfy the capacity of the market. So we're supposed to work on to and the biopolymers in such a system where it can be scale up to and the higher TRL levels and the higher consumption or the capacity fermenters by which we can satisfy the need of a polymer, replacing synthetic plastics in that many tons of the material per day. So starches, carbohydrates, saccharides, carrageenans, these are available naturally, but their natural availability is also not that level of abundance where the plastic industry's need will be satisfied. So do join hands with sustainability approach in the polymer industry to work on to and the bioplastics which can be scaled up to and the larger extent. By that way, the availability of the bioplastics will be, and the second part, as the larger volumes will be, the cost can be target and the managed to. So this all which we have been doing it into and this lab where whole research group of mine, which we call it as an STM research groups, are been working with the facility which we have generated completely from the industry. It is nothing to do from the other project sources. It is only on the industrial fundings. Why I'm been narrating the that particular part, because industry fundings associated with the objectives and deliverables, that to be with the timeline. So only knowledge will not succeed you professionally. Knowledge is must, but you should know how to practice your knowledge for the betterment of commercialization of the country and the betterment of service life or the society. And at the last, I thank you, every one of you. And what I could able to share my thought process is because of whole sum of people which you all could see in this photograph are the inputs given to me, which I am been just percolating to you. So I first of all thank you all, to you all faculties of your PIU, and specifically to the Professor Kiran Patil, who is at the helm of affairs at this moment. And we are always been in hands with the PIU as an ICT and me to strengthen up the activities at PIU, specifically related to polymer engineering, and our expertise lies there. So thank you very much.
Thank you for the wonderful presentation. It
Thank
was
you.
even something really nice, having been off of research for so many years. It was surely a great food for thought. I mean, personally as well.
Thank you. You were been from this place, so you know how the struggle of
Yes.
from converting this into this. But then, due to and the innovation and opportunity is the only way forward. And you were been always into and the research as your motive to do, which I am well aware about. But thank you, Prashant.
Thank you. Nice presentation, sir. Thanks a lot. Yeah.
Thank you,
Yes.
Dr. Mhaske.
Thank
As we come to the close of today's session, I would like to take a moment to express our heartfelt gratitude. On the behalf of Plastindia International University, Vapi, I sincerely thank Professor Shashank Mhaske for your insightful sessions on the advances in biopolymers, ranging from their applications in sustainable packaging and additive manufacturing to automation strategies for scalable productions, smart recycling technologies, and their future directions for circular and eco-conscious polymer innovations. A special thank you to Dr. Prashant Gupta for providing valuable insights into how PIU is shaping the future of polymer science and sustainable technologies. To all our participants, thank you for joining us for this 7th edition of the Parivartan Webinar Series. We hope you found today's session enriching and engaging. Join us in our upcoming sessions as we continue exploring into key themes shaping the future of technology, sustainability, and innovation. Thank you, everyone. Thank you, sir.
Thank you.
Goodbye.
Thank you, Dr. Prashant. And please let me know. I am one phone call away for you, whatever you
Yes, sir. Thank you. Thank you.
take care. Take care. Bye.